GFCI protection is indeed required for hand dryers according to the National Electrical Code, specifically the 2020 edition. Section 210.8b3 mandates GFCI protection for all 125 volts, single-phase, 15 amps and 20 amps receptacle outlets installed in locations listed in 210.8a, which includes bathrooms. Furthermore, Section 410.42d explicitly mentions hand dryers as a device that necessitates GFCI protection within bathrooms. The rationale behind this requirement is that hand dryers are categorized as wet location equipment due to their closeness to water sources like sinks and faucets. GFCI protection is absolutely vital in preventing electrical shock should a ground fault occur. A ground fault can happen when water or moisture inadvertently comes into contact with exposed electrical components. As a result, GFCI protection is essential to ensure electrical safety. In practical application, GFCI protection must be implemented for all hand dryers, irrespective of their type. This encompasses both hardwired and plug-in models. GFCI outlets can be integrated either within the electrical panel or as independent devices situated near the hand dryer. For hardwired hand dryers, a GFCI circuit breaker should be installed within the electrical panel. An exception to the GFCI requirement exists for hand dryers integrated into a listed equipment assembly. An example would be a combination sink and hand dryer unit where the manufacturer has already incorporated integral GFCI protection. In summary, GFCI protection is mandatory for all hand dryers installed within bathrooms. This safeguard is crucial in preventing electrical shocks and ensuring electrical safety in the event of a ground fault. Understanding the nuances of the National Electrical Code (NEC) requirements for ground fault circuit interrupter, GFCI protection of hand dryers is crucial for ensuring electrical safety, especially in environments prone to moisture like bathrooms. The NEC, in its 2020 edition, addresses this specifically, and it's essential to delve into the relevant sections to grasp the full scope of these regulations. Section 210.8b3 is a key reference point. This section mandates GFCI protection for 125 volts, single-phase, 15 amps and 20 amps receptacle outlets located in areas outlined in 210.8a. Bathrooms are explicitly included in this list. Therefore, any receptacle outlet in a bathroom must have GFCI protection. However, the application to hand dryers becomes even clearer with Section 410.42d. This section directly addresses luminaires, lamp holders, and pendant fixtures and states that in dwelling units, GFCI protection shall be provided for 120 volts through 277 volts luminaires, including lighting equipment associated with these fixtures, and receptacle outlets installed in bathrooms. This includes hand dryers. Hand dryers are considered equipment installed in bathrooms, thus falling under this requirement. The primary reason for this requirement is the inherent risk associated with electrical equipment in wet locations. Bathrooms, by their nature, involve water. Hand dryers are often located near sinks and faucets, increasing the likelihood of water exposure. This proximity to water elevates the risk of electrical shock if a ground fault occurs. A ground fault happens when there is an unintentional electrical path between a live conductor and ground. If a person comes into contact with a faulty appliance or wiring in a wet environment, the electricity can flow through their body to the ground, resulting in a potentially lethal shock. GFCI devices are designed to detect these ground faults. They constantly monitor the current flowing in the circuit. If there's an imbalance, indicating that some current is leaking to ground, the GFCI will quickly trip, cutting off the power and preventing an electrical shock. In terms of practical application, the NEC requirements mean that all hand dryers installed in bathrooms, whether they are hardwired or plugged into a receptacle, must have GFCI protection. For receptacle-type hand dryers, the solution is relatively straightforward, using a GFCI receptacle. These receptacles have built-in ground fault protection and can be easily installed in place of a standard outlet. However, hardwired hand dryers require a different approach. In these cases, the GFCI protection must be provided by a GFCI circuit breaker installed in the electrical panel that feeds the hand dryer circuit. This breaker serves the same purpose as a GFCI receptacle, monitoring the current and tripping if a ground fault is detected. It's also important to note that simply relying on the building's overall grounding system is not sufficient. While proper grounding helps to minimize the risk of electrical shock, it doesn't provide the same level of protection as a GFCI. A ground fault can still occur even with a properly grounded system, and a GFCI is needed to quickly interrupt the circuit and prevent injury. There is an exception to the GFCI requirement. If a hand dryer is part of a listed equipment assembly and the manufacturer has integrated GFCI protection into the unit, then additional GFCI protection is not required. A common example is a combination sink and hand dryer unit where the entire assembly is designed and tested to provide ground fault protection. In such cases, the manufacturer has taken responsibility for ensuring the safety of the product. When installing or maintaining electrical equipment in bathrooms, it is essential to adhere to the NEC requirements for GFCI protection. This is not only a code requirement, but also a critical safety measure to protect individuals from the risk of electrical shock. Always consult with a qualified electrician to ensure that your electrical system is up to code and properly protected. Remember that electrical codes and regulations can change over time. Always refer to the latest edition of the NEC and any applicable local codes to ensure compliance. The goal of these codes is to provide a safe electrical environment for everyone. Ground fault circuit interrupters, GFCIs, are crucial safety devices designed to protect individuals from electrical shock. They work by monitoring the current flowing in a circuit and quickly disconnecting the power if a ground fault is detected. Understanding how GFCIs function and where they are required is essential for electrical safety. A ground fault occurs when there is an unintended path for electricity to flow from a live conductor to ground. This can happen if the insulation on a wire is damaged, or if water comes into contact with electrical components. If a person touches a faulty appliance or wiring during a ground fault, electricity can flow through their body to the ground, causing a potentially fatal shock. GFCIs are designed to detect these ground faults by constantly monitoring the current flowing in the circuit. They measure the difference in current between the hot wire and the neutral wire. In a properly functioning circuit, these currents should be equal. However, if a ground fault occurs, some of the current will leak to ground, creating an imbalance between the hot and neutral wires. When the GFCI detects this imbalance, it quickly trips, cutting off the power in a fraction of a second. This rapid response is crucial in preventing electrical shock. The tripping threshold for a GFCI is very low, typically around 5 mA. This means that it can detect even small ground faults that might not be noticeable to a person. The NEC mandates GFCI protection in various locations where there is an increased risk of electrical shock. These locations include bathrooms, kitchens, garages, outdoor areas, and construction sites. In bathrooms, GFCI protection is required for all 125 volts, single-phase, 15 amps and 20 amps receptacles. This includes receptacles near sinks, tubs, and showers. The reason for this requirement is the presence of water, which increases the risk of electrical shock. In kitchens, GFCI protection is required for receptacles serving countertops. This is because kitchens often have water and appliances that can create a risk of ground faults. Garages also require GFCI protection for all 125 volts, single-phase, 15 amps and 20 amps receptacles. This is due to the potential for moisture and the use of power tools and equipment that can create a risk of electrical shock. Outdoor areas such as patios, decks, and pools also require GFCI protection for all receptacles. This is because outdoor environments are exposed to the elements, increasing the risk of electrical shock. Construction sites are particularly hazardous environments, and GFCI protection is required for all 125 volts, single-phase, 15 amps and 20 amps receptacles used on site. This is to protect workers from the risk of electrical shock. GFCIs come in two main types: receptacle type and circuit breaker type. Receptacle type GFCIs are designed to replace standard receptacles. They have a built-in ground fault protection and can be easily installed in place of an existing outlet. Circuit breaker type GFCIs are installed in the electrical panel and provide ground fault protection for an entire circuit. They are used to protect hardwired appliances and equipment that do not have a receptacle. When installing or testing GFCIs, it is important to follow the manufacturer's instructions and any applicable electrical codes. GFCIs should be tested regularly to ensure that they are functioning properly. This can be done by pressing the test button on the GFCI. If the GFCI trips, it is working correctly. If it does not trip, it should be replaced. It is also important to avoid overloading GFCIs. Each GFCI is designed to protect a certain amount of current. If the current exceeds this limit, the GFCI may trip. If you are unsure about the GFCI requirements in your area, consult with a qualified electrician. Electrical safety is paramount, and it is always better to be safe than sorry. Understanding the function and application of GFCIs is a critical step in protecting yourself and others from the risk of electrical shock. Regularly test your GFCIs and ensure that they are properly installed and maintained. When dealing with electrical systems, always prioritize safety and consult with a qualified professional if you have any questions or concerns. The NEC provides specific guidelines for the installation and use of GFCIs, including requirements for wiring, grounding, and overcurrent protection. Always adhere to these guidelines to ensure that your electrical system is safe and compliant. Ignoring or bypassing GFCI protection can have serious consequences, including electrical shock, fire, and property damage. It is never worth taking the risk. Protect yourself and your loved ones by ensuring that your electrical system is properly protected with GFCIs. Regular inspection and maintenance of your electrical system can help to identify potential hazards and prevent electrical accidents. Hire a qualified electrician to inspect your electrical system at least once a year. This can help to identify any potential problems and ensure that your electrical system is safe and up to code.